Hello everyone, welcome to the channel Top Gate. In this video, we'll discuss the process states and we'll also discuss what is a program, what is a process, and what is the difference between a program and a process. So in the previous lectures, we have seen what is an operating system and why we are studying this process state. Right? So if we go back to the previous lecture, the first lecture that I gave, in that one I told you that the functions of the operating system is to act as a resource manager, and the resources that it has to manage are four. That is, first one is the CPU, second one is the main memory, third one is the secondary memory, and the fourth one is the input-output devices. So we are right now discussing the very first resource of the operating system that it manages, and that resource is the CPU. And in that CPU, the most important thing is the process. Okay, so before studying what a process is, we should know what a program is and what is the difference between a program and a process. So with the help of the program, I'll move on to the process, and then I'll tell you what is the state diagram or what is the state transition of a process. So let's start with the lecture. So first of all, what is a program? A program is a logical sequence of instructions. That is, if I need to use the capabilities of the hardware of the computer system, then to instruct that hardware, we have to write some logical sequence of instructions. Okay, and these logical sequence of instructions are basically telling the hardware to act as per the needs of the user. Fine. So whenever we write a program, it is not doing anything. It is only a sequence of instructions. We save it onto the hard disk, and this program is only sleeping. It is not doing anything. So we can say a program is a passive entity which does nothing by itself. Fine. Now, as soon as we execute that program gets converted to a process. That is, it gets converted to an active entity. So we can say a program which is in execution is a process, or we can say a program is a passive entity and a process is an active entity, and this process is actually doing for which it has been written for. Clear? Now come to this diagram. This diagram is called as the process state diagram or a process transition diagram. That is, as soon as the process is created, it goes to the new state. Fine. And in the new state, it starts acquiring the resources it requires for its completion. That is, it informs the operating system that I need particular resources for my completion. That is, it may tell the operating system that I need some space on the RAM, I need some hardware, I need some other thing, some other input. So all these requirements it put as a request to the operating system, and after the operating system accepts these requests, it allocates all those resources to the process which is acquiring the resources. Now, as soon as this process completes its acquiring of the resources, it informs the operating system that now I have acquired all my resources, all the allocation has been done, now I am ready to begin the execution. So as soon as it tells this to the operating system has one component called as the long-term scheduler. So the operating system informs this component that is called as the long-term scheduler, and it instructs the long-term scheduler to pick that process from the new state and send it to the ready state. Fine. Now sending it to the ready state means this ready state is there on the RAM. That is random access memory or the main memory. So whenever a CPU has to execute any process, that data should be residing onto the RAM. Why? Because the access speed of the RAM is very fast as compared to the secondary storage. So here the program was there and it was there onto the secondary memory. It was not doing anything. It was only trying to acquire its resources. As soon as it completes its requirements, it informs the operating system that now I have completed all my resources. And the operating system in turn instructs the long-term scheduler to pick that process from the new state and sends it to the ready state. Clear? And in the ready state, we can have several processes. That is, processes are coming there in the new state, they are acquiring their resources, and they are informing the operating system that they are ready to begin the execution. The operating system is instructing the long-term scheduler to pick that process from the new state and send it to the RAM in the ready state. So we can have several processes here in the ready state, and so we have a ready queue here. So all the processes who are there in this ready queue are actually waiting for their turn to be executed by the CPU. Now at this point we have another component which is called as the short-term scheduler. Short-term scheduler. So the short-term scheduler picks one process from the ready state and it dispatches it to the running state to the CPU for execution. Now dispatching it onto the running state does not mean that we are sending the process from one place to another. It is already there in the RAM. The process is there on the RAM here also. It is there on the RAM here also. Okay, the only thing that we are doing here is we are changing the state of the process from the ready to the running state. We are only instructing the CPU that this process is now ready, you have to execute this particular process. Fine. Now this we are discussing for the case of a uniprocessor system. Fine. If we have multiple processors, we can execute multiple processes simultaneously at a single time. But since we are discussing a uniprocessor system, that is, there is only one CPU and this CPU can execute only one program at a time. It cannot execute several processes at a time. Fine. So the process was there waiting in the RAM, and the short-term scheduler was picking one process from the ready state and sending it to the CPU for execution. Now, what is the basis on which this short-term scheduler picks the process from the ready queue? Now, this depends on CPU scheduling algorithms. So, we have certain algorithms. We'll be discussing all the algorithms in detail in the upcoming videos. So, on the basis of some CPU scheduling algorithms, we have some CPU scheduling algorithms. So on the basis of some CPU scheduling algorithms, it picks one process from the ready queue and it dispatches it to the CPU, and the state of that process changes from the ready state to the running state. Fine. Now there are several processes which are waiting for their turn in the ready queue, and one process is getting executed here in the CPU, and the state of that process is the running. Now this process which is being executed in the CPU has two options. Either it can complete the first option, either it can complete its work and exit and gets terminated, or the second option is that when it was getting executed, suddenly it informed the operating system that now it needs some output for its execution. Fine. So that is, it needs from suppose it needs some data which is there on the secondary memory. Now the process which was in the running state was residing on the RAM. Fine. And the access speed of the RAM is very fast as compared to the access speed of the secondary storage. So taking the input from the secondary storage will actually take a lot of time. So what operating system will say, it will ask that process to leave that CPU for a moment and go to the waiting state, and in the waiting state it can complete its output whatever it needs for its execution. Fine. And meanwhile, when this process shifted to the waiting state, another process on the basis of some algorithms, CPU scheduling algorithms, was picked from the ready state and it was dispatched to the running state. Fine. So this cycle goes on, and now the process which was waiting in the waiting state, which was waiting for some output or some event completion, so after it completed its work, it is again sent to the ready state. Now we are not sending this process which was waiting from waiting state to the running state. Why? Because there is already some process running in the CPU. So therefore this process which was waiting in the waiting queue, when its work was completed, that is output or event completion, so when its work was completed, it was again sent to the ready queue, and now it is again waiting for its turn. So again, the short-term scheduler will pick that process from the ready state and send it to the running state for execution. Fine. So that was the second option. Now, these are the primary states in the process. There are some other states which usually are not mentioned in some of the books, but I have specifically mentioned that. The reason behind that is, suppose we have 20 processes which are waiting in the ready queue for their execution. Fine, all the process needs to be executed by the CPU. So the short-term scheduler picks one process from the ready queue and sends it to the running state. Fine. Now, after completing part of its work, that process informs the operating system that now I need some input output. I'm not completing my work, I need some input output. So getting that input output will actually take a lot of time. So the operating system will ask that process to leave the CPU for a moment, and it will send the process from the running state to the waiting state. So the process is there in the waiting state, and this is also a queue. So this process is waiting in the queue, and it is waiting for the completion of the input output, whatever it has the requirement. Clear? Now, meanwhile, the second process was picked by the short-term scheduler, and it was sent again to the running state. Now, that process also informed the operating system that it also needs some input output. So the operating system again will shift that process from the running state to the waiting state, and the process is waiting in the waiting queue. Third process, again, it was picked by the short-term scheduler and sent to the running state. That process also informed the operating system that now it is not completing its work, it needs some input output. So the worst case can be that all the 20 processes which were there in the ready queue, instead of completing their work, they needed some input output, and they were shifted from running state to the waiting state. These processes are waiting in the waiting queue, and they are not able to get their requirements. So instead of increasing the load on the RAM, what we'll do, we'll shift these processes from the RAM to the suspense state, from this waiting state to the suspense state. Now this suspense state is on the you can say on the secondary storage. Fine, it is there on the secondary storage. So instead of putting so much load on the RAM, we will shift these processes from the waiting state. We will swap out these processes to the secondary storage, and the status of these processes will be changed to the suspend wait. They are waiting in the secondary storage now. Why? Because they are taking longer than the usual time to complete their input output. So instead of doing this work on the RAM, they'll be swapped out and they'll be completing their work on the secondary storage. Fine. Now, as soon as they complete their input output, they'll be again swapped into the waiting state, and then at this state they will inform the operating system that now I have completed my input output, and then the operating system will shift that process from the waiting state to the ready state. Now this swap out and swap in work will be done by another component of the operating system, that is called as the mid-term scheduler. Fine. So we have three schedulers. One is a long-term scheduler, which is sitting here. Second one is a short-term scheduler, which is sitting here. Third one is a mid-term scheduler, which is sitting here, and it is responsible for swapping out the process from the RAM to the secondary storage, or from the waiting state to the suspend wait. Clear? So this process, after completing their work in the secondary storage, they'll be shifting to the waiting state, and from the waiting state it will be again fed to the ready state, where this process will wait for the turn to be executed by the CPU. Now this cycle will go on and on unless and until all the processes have completed their work and they have got terminated. Fine. So thank you so much.